So we're gonna talk about polar coordinates, and today we're gonna focus on defining the polar coordinates and drawing some sketches on them. And then tomorrow we're gonna dive into how they are related to rectangular coordinates. Okay, so come and pick up a note sheet if you didn't already. Okay, and then we're going to start by just defining a few things on this diagram. So we've talked about how it uses distances and directions to specify the location. We're always going to start with the polar axis. It's very similar to how we always start at the same place when we're graphing an angle on the unit circle. Okay, so this is your polar axis. Okay, and then you're always going to have the pole at the origin. Okay, and you can use those words interchangeably. And then your value of r is going to be the distance from the origin to the point P. Okay, so the value of r is the distance from the origin to the point. Okay, so we're going to say from O to P. Okay, O for the origin, P is going to be for the point, and then we are going to write that point as r theta. Okay, like I said, we're going to practice putting those in brackets. In the second part of the notes, that is how you will see those. Okay, and then in this diagram here, if the r value is less than 0, okay, if the r value is negative, then when you are calculating your theta, that's going to be in the opposite quadrant, which we've already mentioned today, that's pi units away. And then they do specify that the distance here for r is the absolute value of that. And then again, your point is going to be r and then theta. It's just your r value is going to be negative. Okay, this is still going to be the same form. Now your theta value is positive if you are traveling counterclockwise and negative if traveling clockwise. Okay, we already know that from the unit circle. If r is negative, then you're going to go the absolute value of r units from the pole in the opposite direction of theta. Okay, we're going to look at this picture together, and then we are going to draw it here.
Teachers, please pardon the interruption. At this time, please release all bowlers.
Okay, and in this figure, it is going to show you that r theta and negative r, theta plus pi, represent the same point. Okay, so in this space here, we are going to draw figure 4. And we are going to be drawing several of these diagrams today, so I always start with the pole. might notice above this diagram that you do have the same text that we had on our packet today. Okay, this is just factoring out the pi. And we're finishing that up. Also just going to take a look at some of these examples above. So these are examples of what we're going to be drawing. Okay, something like this is negative 4 pi over 4. This one's a negative pi over 6, 3, and you can see like we have the dashes on there. Okay, so we're going to be drawing some of those without the plane. Okay, and then if you want to just check your figure with them, you can as we head on to example 1. So in example 1, they ask you to plot the point that has the given polar coordinates. Then you have to give 2 other polar coordinate representations of the point. One of them is going to have a negative r value, and the other is going to have a positive r value. Okay, so the steps 1 through 3 are all about the drawing. We're going to start with the pole and the polar axis. Okay, so for A, we have 1/2 pi over 6. So we're just going to start with O and the polar axis. Okay, that's always where you're going to start. And it's a little slanted, but all right, then we're going to draw the angle. So that is 5 pi over 6. So that is 30 degrees away from a straight angle. And the way that you notate that is you draw the angle and you identify that theta is 5 pi over 6. That is step 2. So step 1, you draw the polar axis with the pole. You're going to rotate to theta, and then you're labeling your drawing. So in this case, it's 1/2. Okay, so if you just want to label this part, if your 1 check mark is 1/2, and then you're going to label your point P. Okay, point P is 1/2 5 pi over 6. Okay, I know it gives it to you with the soft brackets. For this exercise, you can use either one, but our polar form is going to have those hard brackets. Okay, so you just completed steps 1 through 3. Okay, that's your drawing. For step 4, you are going to find the 2 other points. So to do that, you can add and subtract 2 pi to theta for the given value. Sometimes the given value is negative, and that's okay. It's whatever your given value of r is. Okay, so whatever's given in the problem here. Okay, and then for the next point, you're going to replace r with the opposite. And once you replace it with the opposite, that is when you add or subtract pi, because it is pi units away. So for part A, you are given that r is positive. So you're going to start with that positive value of 1/2. Okay, whatever you are given, you are adding 2 pi, or you are subtracting 2 pi, because that would be 1 rotation on the circle. Okay, you want it to be the same place. So we're going to do 5 pi over 6 plus 2 pi, or we can do 1/2, 5 pi over 6 minus 2 pi. Okay, go ahead and simplify that. Okay, so if you add 2 pi, that's like you're adding 12 pi over 6. So 12 plus 5 is 17 pi over 6. Okay, and then if you subtract 12, you get negative 7. So negative 7 pi over 6. The second part is going to be the opposite. Okay, so in this case, your opposite is that r is negative. Okay, so you're going to have negative 1/2. And then because you have the opposite here, we're going to add or subtract pi to the original. So we can do 5 pi over 6 plus pi. Or we can have negative 1/2, 5 pi over 6 minus pi. Okay, so if you're adding pi, you're just adding 6. So 5 pi plus 6 pi is 11 pi over 6. When you subtract 6, 5 pi minus 6 pi is negative pi over 6. Those are going to be your two negative answers. Okay, if you haven't already put your treasure hunt in the bin, again, just make sure your name is on it and that you have that turned in so I can give you your points.